Hi guys, welcome to another video of Physics 2. In this case, we got this problem, and here we're going to combine the motion in one dimension and the Newton's second law. But we're gonna see that in a moment. So we got this problem. It says a car travels at 34 meters per second in a straight line and brakes with constant acceleration, traveling 75 meters before stopping. If the car waits, let's say that this is a new data that we have, because in the previous problems they didn't give us the weight of the object. What is the magnitude of the force to stop the car? Okay, so I'm gonna make the drawing. So this is the car. Just remember that I'm not very good at making drawings, so please bear with me. Okay, so remember, if the problem does not mention the direction of the object, I'm going to suppose that the direction goes to the right, okay? Because in the reference system, everything that goes to the right is positive, okay? So the car is moving, and I'm going to say that, remember that most of the times the initial position is 0 meters, unless the problem says something about it. Okay, so the car travels at this velocity, so it doesn't say that it's going to change or something. I mean, it says that the car is traveling at this velocity, and in a moment it's going to stop. So I'm going to consider that this is a constant velocity. Okay? But for example, the problem begins here at this point. So the car in the past, let's say in the past, okay, was traveling at that velocity, constant velocity. So the car begins when the person inside here is going to push the brake. So initial velocity equals 34 meters per second. So of course, it's going to brake, so that means that the velocity is going to decrease. But of course, the car is going to continue moving forward, but the velocity is going to decrease. Okay, so in a certain point, the car is going to stop. It's going to finally stop because the brakes reduce the velocity of the car. So at that point, I got the final position. Okay, the car traveled 75 meters before stop. Okay, this 75 meters in this traveling, the car has acceleration. Okay, so the final velocity here is 0 meters per second. So it is very important to mention that if the car is going to stop, so that means that there will be something that is going to be in opposite direction. It's going to oppose, or is going to be against the motion. So that would be the acceleration. So that means that the acceleration is going to be negative. And of course, that we're going to see it in a moment, there will be a force that is going to generate that acceleration, and that force also has the direction of the acceleration. So that force is going to be negative as well. Okay, because it's going to change the velocity of the car. Okay, so I'm going to move into another screen. I mean, I just like to do here the drawing. I mean, I really don't like to do the problem. So let's go to the other screen that is here. Okay, so here I'm just going to write the data again. Just hold on, please. Okay, so let's write the data. So initial position is 0 meters. Initial velocity is 0 meters. Oh, sorry, it's not 0 meters. It's 34 meters per second. Final velocity is 0 meters. per second. Final position is 75 meters. The weight is 10,000 newtons. That's the weight of the car. And well, I need to find the force that is going to break the car. Okay, so in order to do this problem, I'm going to write two new equations. The first equation is force equals mass times the acceleration. So this is the Newton's second law. Okay, and the second equation that I'm going to use is weight equals mass times gravity. Okay, and I'm going to circle these two equations because they are very, very important, and I'm going to use these equations through the whole course of Physics 2. Okay, just remember, this is Newton's second law. If there is an acceleration, that means that I have a force. Okay, and the force equals the magnitude of the mass times the acceleration. And remember that the units of the force are newtons. Newtons are kilograms multiplying meters per second square. Okay, so I'm going to write again the formula of force. So force equals mass times acceleration, and I'm going to do the same process of cross mark and check mark everything that I have. So do I have the force? No, that's that's the variable that I need to find. Do I have the mass? No. Do I have the acceleration? No. Okay, that means that I cannot use this equation, but I'm going to write the equation of the weight. Weight equals mass times the gravity. Okay, do I have the weight? Yes. Do I have the mass? No. Do I have the gravity? Yes. The gravity is a constant. So from this equation, I'm going to find the mass. Mass equals the value of the weight over the gravity. Now, there is something I want to tell you. Imagine that, for example, I got this block over here, and this block is above the ground. I mean, it's on the ground. So that means that there is a weight, and the weight goes down. Okay, that's the weight. So using our reference system, the weight goes down, so that means that the weight is going to have a negative sign. And also the gravity, because the gravity is the acceleration of the earth, and the gravity goes down, so that means that I'm gonna have also a negative sign. Okay, I mean, I need to mention that it's not very important here in this problem, but in the problems that we are going to do later, this is gonna be very important, the signs, because remember that the weight is a force, and so the weight is a vector, the gravity is a vector, and the acceleration is a vector, the force is a vector. Okay, so if I use the sign, so that will be minus 10,000 newtons over minus 9.8 meters per second square. Okay, so it's going to be positive, because negative over negative, well, is going to be positive. So the mass equals, let's get the calculator over here. So 10,000 over 9.8 equals this number over here. And if you see, it's an infinite number, so I'm going to save this number in my memory A. Shift STO A. Okay, I already saved the number. Okay, so I'm gonna write it, mass equals 1020.40. I'm just gonna write two decimals, 40 kilograms. Okay, if you want to know why I got kilograms, well, I'm just gonna write, for example, newtons over meters per second square. Remember that newtons are kilograms over meters per second square. So in this case, for example, Newton is in the numerator, so kilograms times meters per second square, and it's going to be divided by meters per second square of the gravity. So that's why I canceled this with this. So I got kilograms. I mean, this is only information if you want to know how we get the units. But if you don't want to do this, just make sure that every time that you divide newtons over meters per second square, you're gonna get kilograms, okay? So if I return to the equation that I got here, so I still don't have force. I have mass now, but I don't have the acceleration. So that means I cannot use that equation. But what I'm going to do, well, I'm going to write the two equations that I got. Do you remember? Acceleration equals final velocity minus initial velocity over time. And the other one is final position equals initial position plus the initial velocity that multiplies time plus the acceleration times square over 2. Okay, do I have the acceleration? Nope. Final velocity? Yes. Initial velocity? Yes. Do I have the time? No. Okay, remember I told you, if in an equation I got 2 or more cross marks, I cannot use that equation. So I need to go to the other equation and do exactly the same process. So final position, do I have it? Yes, I have final position, initial velocity. I don't have time. Acceleration, no, I don't have it. And time, of course, I don't have it. So in this case, you can say that we got 3 cross marks, but honestly, we just got 2 because t and t, well, they are the same. But obviously, I cannot use this equation nor this equation. So what can I do? Okay, before I continue, I'm going to cancel the terms that are 0. So for example, in this case, the final velocity is 0. Okay, and in this case, the initial position is 0. So I'm gonna write the equations again. Acceleration equals minus initial velocity over time. And oh, it's so small, over time. And the other one, final position equals initial velocity that multiplies time plus the acceleration times square over 2. Okay. So, what can I do? Are you ready for the massacration? I really like that word. Okay. So, this is what I like to do. Remember I told you one of the videos I told you that you can look for many formulas. There are many formulas that we can use and you can memorize them. I mean, I really don't know them because I don't like to memorize equations. Only the one that I'm just writing. Only this one, and this one. The other equations, I'm gonna get them using just algebra. So if you see, I got the acceleration. In this case, the acceleration is this, minus initial velocity that multiplied over time. Okay, so this is the acceleration. If you see in the other equation, I just got acceleration too. So what I'm going to do, I'm just going to do a substitution. So that means that this value of the acceleration, I'm going to put it here, okay, in the acceleration of the other equation. Now, this is one of the things that you can do. For example, in this case, acceleration is already isolated. You can isolate initial velocity and you can substitute the value of initial velocity here, or you can substitute the value of time if you want to isolate time, and you can substitute it here and here. I mean, it's up to you. This is something that I do. I mean, you can do the other two options if you want to see the equation. Of course, it's not going to be the same equation. You're gonna get different equations depending on what you have and what you're going to substitute. Okay, so For example, I got students, so teacher, can I just memorize the equation? Well, if you want to, but you need to make sure in which moments you are going to use that equation. I mean, you cannot use it all the time. Okay, but I'm talking about the future. So let's do this. Okay, so I'm going to substitute this term over here in this equation. So let's write it. I'm going to write this equation again. So final position equals initial velocity that multiplies time plus the value of the acceleration, and the acceleration is this one. So I'm going to change color. That is parentheses minus initial velocity over time. That is the value of the acceleration. And this will be multiplied by time square over 2. Okay, I haven't done anything. I just substitute the value of the acceleration and I put it here. So it's here. Okay, and if you see t squared is in the numerator. Okay, so t squared is going to multiply initial velocity. So let's continue writing the equation. Final position equals initial velocity that multiplies time. Positive times negative is going to be negative minus initial velocity that multiplies time square over time over 2. Okay, because time square is going to multiply initial velocity. Okay, is here, and t is in the denominator is here, and everything, all this numerator is going to be divided by 2. I got this 2 over here. Okay, so I'm just writing the equation. I'm just making order in the equation. So next, what I'm going to do, I'm going to cancel these t's using the properties of the exponent. So if I got t squared over t, well, the exponent is going to be canceled with this t. And the answer that I'm going to get is t. But where? In the numerator, not the denominator. I'm just going to get t in the numerator. So that's what I'm going to do. This square is going to be eliminated with this t, and I'm going to get the t in the numerator. So the equation will be final position equals initial velocity that multiplies time minus the initial velocity times the t that I got here. Okay, now I got rid of this t, of this time, and now that I don't have that time, okay, everything will be divided by 2. Boom. Okay, and then next, what can I do? If you see, well, I got initial time and initial velocity and time, and here I got initial velocity and time. Okay, if it's something, if I have x plus x equals 2x, okay, I can add them because I got the same variable. If I have x plus 3x, okay, I got 4x. Okay, and if I have x plus over 2, okay, so this is 1 and this is over the 1 over 2. So I will have, or you can write 2x over 2 over 2, because 2 over 2 equals 1 plus x over 2. So the answer will be 3x over 2. Okay, if you see, well, I got the same variable. Imagine that this is x and this is also x. So 2 plus 1 is 3 over 2. Of course, they got the same denominator. In this case, they don't have the same denominator. Okay, but I can do something like this. Okay, I can do 2 initial velocity that multiplies time. I'm just gonna change the color. 2 initial velocity over 2 minus initial velocity time over 2. Okay, so if I want to get them in the same denominator, well, it will be 2 times initial velocity that times minus initial velocity time. And so this 2 minus 1, well, I gonna get 1. So initial velocity that multiplies time over 2. Okay, 2 minus 1 is 1. I I hope I make myself clear because they have the same term. They have the same variables. It's just like adding the same variables. I mean, when I explain this in class, um, I mean, I use another procedure, but I guess that procedure that I use, I guess it confused my students, so I prefer to do this. I mean, just simple math. So the answer that I'm going to get after making this subtraction, well, it will be final position equals initial velocity that multiplies time over 2. Okay, I'm going to circle this equation. So, do I have final position? Yes. Do I have initial velocity? Yes. Do I have time? No. And if you see, now I got a new equation where I just got one cross mark. Now I can use this equation. One student asked me, teacher, can I use this equation always? Can I memorize this equation? Well, I guess you know me. I would say no. I don't recommend you to do it because this equation, you cannot use this equation if you don't have acceleration. You can use this equation only if you got acceleration and only if the final velocity is 0 and only if the initial position is 0. If you got final velocity and of course initial velocity, this equation is going to change. So I mean, it depends on the problem. But it's up to you. I mean, in the end, I'm not gonna tell you what to do. So what I do is to deduce the equation by having my tools. These are my tools. My tools are just two equations, and from these two equations, well, I got this new one. Okay. And don't worry, in the future we'll see more problems, and maybe you will get experience and you get skills by making substitution and everything. But of course, you need to practice. If you wish to learn physics without practicing, I mean, I guess it's not going to be possible. So sorry, not in this universe. Or maybe you are talented, but of course. Okay, let's continue, guys. So from this equation, I'm going to isolate time. So time equals 2 times the final position over the initial velocity. Okay, so this will be 2 times 75 meters over the initial velocity, that is 34 meters per second. So meters will be cancelled with meters, and I'm gonna have seconds. Okay, time. Let's get the calculator over here. So fraction 2 times 75 over 34 equals, this is an infinite value, so this value I'm gonna save it in B. Shift STO B. Okay, there you go. And I'm just gonna write 2 decimals. 4.41 seconds. And this is going to be saved in the B memory. Okay. Now, but I still need the acceleration. Okay. In order to find the force, I need the acceleration. But if you see, I got this equation over here. Okay, acceleration equals minus initial velocity over time. Now that I got the time, now I can get the acceleration. So I'm gonna do something like this. I'm going to continue with this equation, but I'm going to continue over here. So I'm gonna write acceleration. I'm gonna write it again. Acceleration equals minus initial velocity over time. Okay, and I'm going to substitute. Minus 34 meters per second over the value of time, that is 4.41 seconds. Okay, so if I do that, let's do it in the calculator. It will be fraction minus 34 over the value that I got saved in B. Remember that the time is saved in B, so B equals, that is the value of the acceleration. It's an infinite value, so shift STO C. Okay, and I'm gonna write acceleration equals minus 7 point, I don't remember, minus 7.7. I'm just gonna write minus 7.7. The units, well, if you really want to know what would be the units, for example, we got meters per second and will be divided over second. Okay, but these seconds over here, they got just one, so I'm gonna do outside with outside, inside with inside, so this will be meters per second square. Okay, so the units are gonna be meters per second square. I mean, you don't have to do this every time. I just want to show you, if you are the kind of students that, okay, they want to do the things by their own and you don't like to be told this is it. You don't have to ask. Okay, this is something that you can do. Okay, and this is saved in C. Okay, now let's go back to the equation. And remember, acceleration is negative. Why? Because if I go back to the initial drawing, remember that the acceleration goes in the opposite direction of the motion. Okay, so this acceleration is going to be the responsible of the decrease in velocity. So let's go back to the initial equation. I really like this problem because it's like, okay, we go here and then we go here and then we return, and okay, force I don't have it, mass I have it, and now I have acceleration. So let's do it. Force equals the value of the mass, that is 1020.40 kilograms times minus 7.7 meters per second square. Okay, so, and it's gonna be so easy because this value is, oh, I didn't write it, but this value is in A and this value of the acceleration is in C. So very easy. Alpha A times alpha C, and that is the force. Force, remember that force is a vector, but if you want to be like a cool or something, let's write it with the arrow. Force equals minus 78.63.9455 newtons. Okay, and that is the final answer. Remember that, well, the force has the same direction of the acceleration, and that force is the one that the brakes needs to generate in order to stop the car. Okay, well, I hope you like this video. I mean, it's a very good problem if you ask me. I guess the center point of the problem is deducing this equation that is here. I recommend you to practice. I mean, just remember, in this case, this equation, well, is correct if they don't have initial final velocity, but if you got final velocity, okay, the equation will be different. But maybe in another video I can get another equation using final velocity and also initial velocity. I mean, that equation will be so interesting. Yes, because we're gonna have more variables to play with. Okay, well, I guess This is the longer video that I have, 30 minutes. I hope YouTube doesn't get mad with me. Well, guys, stay tuned and I'll see you in the next video. I hope so. Bye bye.